Lovely. So, Surds revision. What is a surd? I'm going to give you 1 minute to see if you can write down whether each of these numbers are a surd or not. Okay, so if you can write in the chat if you know what a surd is or which ones are surds. If not, I'm going to get started. So root 1 is not a surd because 1 is a square number, because 1 times 1 equals 1. Root 4 is not a surd because it's equal to 2. Root 9 is not a surd because it's equal to 3. Root 36 is 6, so it's not a surd. But root 3 is a surd because 3 isn't a square number. Okay, so that's why we call it a surd. If you were to put it into your calculator, you get 1.732050808, and it actually goes on to infinity, and this is what we call an irrational number. 2 root 3, well, we know that root 3 is a surd, so 2 root 3 is also a surd. 3 root 3 is also a surd, therefore. But 3 root 4, well, you've got to look at this surd and think, I know what the square root of 4 is. It's 2. So this means you have to do 3 times 2 to get 6. So this isn't a surd. If it was left in square root form, then you'd call it a surd. Okay, so if you've got any questions at all, just write it in the chat and I'll keep checking as we go through. Okay, so we're going to start off with simplifying surds. Okay, so I might be going quite quickly in this session, but it's just so I can get all the content that you need done within these 20 minutes. So the square root of 60, the first thing you need to think about are your square numbers. Okay, so I would always quickly list my square numbers on the side. So why don't you list your square numbers now? So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 squared is 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, and 144. So these numbers are going to come in really handy when we're simplifying sets. So you need to look at 60 and think, what is the highest square number from this list that goes into it? So I look at this list and I think, okay, I'm looking below 60, does 36 go in? No, 25, no, 16, no, 9, no, but 4 does. Okay, so 4 goes in 60. So I would write 60 as square root of 4 times the square root of 15, because 4 times 15 is 60. Now, the reason why I use the square root of 4 is because I know what the square root of 4 is, and it's 2. Always put the square factor first. Because if you wrote root 15 times root 4, you would have root 15 times 2, which may confuse you. You might think that that's 152. Okay, so it's nicer to put the whole number at the front. So that's 2 root 15. I'll do one more underneath, so root 120. So again, I look at my square numbers list and I think the highest square number that goes in is actually 4 again. And so I would do root 120 is the same as root 4 times root 30. And I know that root 4 is just 2. And always double check your other number. So root 30, is there another square number that goes into it? If there isn't, then you know you've simplified it as far as it goes. Because I see a lot of students will simplify the surd, but they won't use the highest square number that goes into it. And therefore, the number that's left could be simplified further. One more thing is notice that the square root of 4 I write as 2. If you've seen some of my posts already on my page, and one of the biggest mistakes I see with surds is that a student will simplify square root of 4 to 2, but then they'll keep it in the square root form like this. So that is incorrect. So make sure once you've simplified it, you don't want to see the square root symbol. Okay, can you have a go at these two on the right-hand side for me? So you've got root 25, root 2, which gives you 5 root 2, and that's root 100, root 2. So you've got 10 root 2. Perfect. I'm going to move on. If you have a number in front of the surd, you simplify it like normal, but this 2, you have to multiply with the number that's in front. So root 20 becomes root 4, root 5, and root 4 is just 2. So you times the 2 and the 2 together to get 4 root 5. It's exactly the same method as before. You just have to remember to multiply your answer with the coefficient of 2 in front. And 4 root 40, so you've got the 4 still, and we know that root 40 can be broken down to 4 times 10. So root 4 times root 10. So you've got 4 times 2 root 10, which gives you 8 root 10. Okay, can you have a go at the 2 on the right-hand side, please? Okay, so start finishing what you're on. Excellent, good. So you've got 3 root 20, so that becomes 3 root 4 root 5. So that is 3 times 2 root 5, 6 root 5. Good. And the next one, 4 root 50. Well, we know 50 can be broken down into root 25 times root 2. So that is 4 times 5 root 2 gives me 20 root 2. Excellent, thank you. Right, okay, so moving on. So that's how we simplify surds, the biggest skill that is included in all the other skills we need. Now we're going to quickly look at addition and subtraction of surds. Okay, so make a note of that. Addition and subtraction have the same rules. So it's just like in algebra. If you were to add 2a plus 5a, you would get 7a because the letters are the same. So in surds, you have to make sure that the surd is also the same to be able to add or subtract it. So we would do 2 root 5 plus 5 root 5, which just gives you 7 root 5. The one below, if you notice, you've got 2 root 20 plus 5 root 5. Well, can you simplify this first? So root 20 is root 4 times root 5. And that gives me 2 times 2 root 5, which is 4 root 5. So because the surds are the same now, I can add them together. So 4 root 5 plus 5 root 5 is 9 root 5. Okay, and the last one, you've got 2 different surds here. So I look at them and think, oh, I can simplify the 2 root 20. We just did it above. So we know that's 4 root 5. However, once simplified, the surds are different. So you cannot simplify this further. Okay, so can you have a go at these 3 for me, please? I'm going to give you about 30 seconds. Okay, start finishing what you're on. Okay, so the top one, you should have 7 root 6. Perfect. The next one, the root 54, simplifies to root 9 root 6. So you get 2 times 3 root 6. And then you add it to the 5 root 6 to get 11 root 6. And the one at the bottom, 2 root 20, we've done before. So that's 4 root 5 plus 5 root 15. That is as simplified as it goes. Okay, any questions you can write in the chat. I'm moving on. So just before I move on, sorry, just remember this is the same rules for addition and subtraction, and it's going to come into play once we do some expanding brackets. Now we're going to look at multiplying surds. Okay, so the first one, root 6 times root 6. Well, when you're multiplying, you multiply the numbers inside the surds together. So this gives you root 36, which is just 6. So what you should notice is that because they're both the same numbers, it's as if the square root cancels out. The next one, root 3 squared, that is the same as root 3 times root 3, which is root 9, which is, in other words, 3. Once you're confident, you don't have to do this long working. You can just write 3 as your answer. The third example, so we have the two numbers in the surds, which we multiply together to get root 30. And this is a 2 times a 1 there, so that's just 2. Look at your surd and think, can I simplify this? In this case, we can't, so this is your answer. And in the last example, you can do 3 times 2, which is 6, and then root 3 times root 6, which is root 18. However, I look at 18 and think, well, there's a square number that goes into it, which is 9. So I'm going to simplify that to root 9 times root 2, which gives me 6 times 3 root 2, which is 18 root 2. Okay, can you have a go at the 4 on the right-hand side for me, please? Okay, so the first one, you should have 5. Second one is 6. Third one is 2 root 35. And 35 doesn't have a square factor, so that's as simplified as it goes. And the last one, 3 times 2, which is 6. Root 3 times root 8, which is root 24. Now, root 24 can be written as root 4 root 6, which gives me 6 times 2 root 6, which is 12 root 6, is your answer. Okay, any questions on that? Right, expanding brackets now. We're going to use this when we rationalize surds as the last part of our lesson today. Expanding brackets with surds is exactly the same as expanding brackets in algebra. So whether you learnt it with the grid method or if you learnt it what we call the FOIL method, both methods will be absolutely fine for this as well. When I said FOIL, if you don't know what that stands for, it means first, so you multiply the first two together, outer, inner, and last. Okay, so let me just rub these out so I can do it together. And so we're going to multiply the 2 and the 4 together to get 8. Then you do the 2 with the root 3. So 2 times root 3 is just 2 root 3, and it's a positive because both of these numbers are positive. The next one, however, is negative root 3 times 4. This is an invisible 1 in front of the root 3. So you do negative 1 times 4, which is negative 4, and then you times it by the root 3. And then you've got negative root 3 times positive root 3. Well, we know from before that when you multiply the same surds together, so let me write it here, root 3 times root 3 is equal to just 3. So negative root 3 times root 3 is just negative 3. Then we can simplify the numbers. That's 8 take away 3, which is 5. And then you've got the 2 root 3 take away 4 root 3. So if you go back to when we were adding and subtracting with surds, you just look at the numbers in front. So 2 take away 4 is negative 2. Don't forget to add the surd at the end. So can you have a go at the right-hand side? I'll give you 1 minute to have a go. Okay. Excellent. We've got some answers coming through. Right, so root 3 times root 3 is 3. Root 3 times 4 is positive 4 root 3. Negative 2 times root 3 is negative 2 root 3. And then negative 2 times 4 is negative 8. So you've got your 3 take away 8, which is negative 5. And then 4 take away 2, which is positive 2 root 3. Well done. Okay, so we've done expanding brackets. We're going to move on to rationalizing surds. So this is the last part of our lesson today. And it's the last skill that you need to learn. We're going to obviously go through it quickly, but just try to take as many notes as you can and ask any questions afterwards. Rationalizing surds. So we do not like to have a surd in the denominator of a fraction, because when we're dividing numbers, we like the number to be a whole number. It's just a lot easier to split into different parts. But we can still do this, and we call this rationalizing surd. So we get rid of there being a surd in the denominator, but we don't change the value of the fraction. So remember, if you want to keep a number the same, you can times it by 1. So we're going to times it by 1, but a different version of 1. And what might that be? Well, we look at the denominator, which is square root of 5. So we're going to times it by a fraction, which is equivalent to 1. And you always use the denominator. Okay, so whatever the denominator is, that is what we're going to use as our fraction that we multiply by. So then you do 3 times root 5, which is 3 root 5. And then we know root 5 times root 5 is just 5. Okay, so there you have it. This fraction has exactly the same value as the one in the question, but we don't have a surd in the denominator now, so it has been rationalized. And if you had a calculator, you put the first one in and it would give you the simplified, the rationalized form anyway. But these always come up in non-calculator papers. The next one, slightly different. There's a 2 in front of the root 5. You can times it by 2 root 5 over 2 root 5, but you don't have to. This actually takes a bit longer to do, and you'd need to simplify the fraction afterwards. So what I recommend is just looking at the surd that you have here, the root 5, and timesing it by that. So the numerator becomes 3 root 5, and the denominator becomes 2 root 5 times root 5. So this is 2 times 1, which is 2, and root 5 times root 5, which is 5. So you've got 3 root 5 over 10. Okay, so notice we don't have a surd in the denominator. Perfect. And the last one, which is the harder examples, when you've got a plus or a minus in between a number, a whole number, and a surd, this time we don't times it by the exact same denominator. We have to change it to have a negative or the opposite sign. So again, this fraction is equivalent to 1 again. It's similar to the denominator, but we change the sign. And when you change the sign, what happens is, while you're expanding the brackets, the surds cancel out. So I would do the numerator and the denominator separately. So 4 take away root 3, which gives you 24 minus 6 root 3. And the denominator, double brackets. So be really careful. It's exactly what we did before. You do 4 times 4, which is 16. 4 times negative root 3, which is minus 4 root 3. And root 3 times 4, which is positive 4 root 3. And root 3 times negative root 3, which is minus 3. So 16 take away 3 is 13. And notice that this is a negative and a positive, so it becomes 0. So the answer to our question is the numerator, which is 24 minus 6 root 3 over 13. Okay, and just look at your whole numbers if you can cancel them out at all, which you can't in this case, and that's your answer. If you can have a go at these 3 questions on the right-hand side, I'll give you a minute to do that, and then we're going to finish up. Okay, I'm just going to write the answers for these three questions. So you've got times root 5 over root 5, which gives you 10 root 5 over 5. And look at these numbers here. That's 10 over 5, which is 10 divided by 5, which is just 2. So make sure you always check if you can cancel anything out. And this one, you times it by root 6 over root 6, which gives you 3 root 6 over 2 times 6, which is 12. Again, 3 over 12, the fraction 3 over 12 simplifies to 1 over 4, which is just root 6 over 4. The last one, you're going to times by 4 plus root 3 over 4 plus root 3. Do it separately. So I'm just writing the answers here for you. That's 24 plus 6 root 3. And the denominator becomes 4 times 4, which is 16, and minus 3. Once you do it step by step, over 30. Okay, so make a note of these answers. And I'm going to leave you with this exam question. Take a screenshot of this, and then we'll finish up for today's lesson. I'll stay on for a few more minutes if you have any questions at all. Also, if you found this lesson useful, I'd really appreciate some feedback. And if you can send me your workings for this last question, I would love to see it. I'll also email you some examples and some more questions for you to have a go at. If you found this session useful, I'm also doing an 11-week course starting in February. So that will go in more depth. I'll be going a lot slower, but we'll be focusing on exam skills, specifically to get the grades 7 to 9 in your exams. So I did send you an extra discount code if you're interested. And if you have any questions, feel free to email me or